Is the relation a function? So a relation between two sets is a collection of ordered pairs containing one object from each set. For the purposes of this video, the ordered pairs are points on the rectangular coordinate system. We will identify functions from their given relations, that are either a set of ordered pairs or a graph on a rectangular coordinate system. So think about a set of ordered pairs as a roster. You wouldn't list the same point twice. Like, think about sports. I always like to take things back to sports. If I am on the football team and I'm a cornerback, a defensive back, maybe a safety, and then I also play running back or quarterback, a wide receiver or something. Say I play on offense and defense. You don't put me on the roster twice, okay? You put me on the roster once, and then you may list out there CB, S, QB, RB, whatever, right? Positions if you have to do that. All right, but you still only put the person on the roster once, the player on the roster once, even though they may play multiple positions. Okay? So if any X value repeats with a different Y value, it's not a function. If any X value repeats, right? So we know that in the rectangular coordinate system, the points, the ordered pairs are X, Y. So if the first number repeats, it's not a function. And here's the deal. You say, well, what if it says 4, 2, and 4, 2? Well, again, why would you list 4, 2 twice? So if it's going to be 4, 2 and then 4 something else, 4, 3 or 4, -8 or 4, 0. So if the X repeats with a different Y, technically, with a different Y. But we just talked about it. You're not going to list the same point twice. So if the X repeats with a different Y, not a function. It's okay, I want you to note, it's okay if the Y repeats, it would still be a function. Okay? For a graph on a rectangular coordinate system, we're going to use something called the vertical line test. And many of you are familiar with this. If any vertical line, and I'll use the word touches here in quotes, the graph more than once. So if it intersects it at more than one point, that's what I'm saying by touches. If it intersects the graph at any vertical line at more than one point, then it is not a function. So let's look through here at these. First, determine whether the relation is a function, given the domain and range, or give the domain and range for each. Again, the domain is the set of X values. The range is a set of Y values, and we know our ordered pairs are X, Y. So this is what we call the roster method. That's why I brought up the roster. This is the first element in the roster, and the element in this case is not just a single digit. It is an ordered pair. Okay, so -1, 9 in parentheses, that point, that ordered pair is the first element. Then you have the comma. Then you have the second element and the comma, and the third element and the comma, and the fourth element and the comma, and the fifth element. And then you have these squiggly brackets on the end. Okay? And forgive me for, saying squiggly bracket. But anyway, if I say that, you know what I'm talking about, I hope. If you have a set, then you must write your squiggly brackets, okay? You must do that. So what we're going to do here is we're going to talk about the domain and the range. And the domain and range are sets, but they're not ordered pairs. They're a set of X values for the domain and a set of Y values for the range. So they're a set. We're going to list them out in roster method, okay? We don't always list domain and range in roster method, but here when we have a finite number like this, 5 elements in our set, we're going to do this as the roster method here. All right. So when I open my setup, if you in my class, if you don't open the setup, I count off because it is a set. All right. So you've got to give me the squiggly bracket there. All right. There's 3 things I want. Give me the squiggly bracket, put commas between your numbers, and don't repeat anything. If you do that, then you're good. Okay. So now you need to make sure you know what your professor, teacher, instructor wants. All right. So here, this is going to be -1. That's the first X value. That goes here. Okay. Now, what's the next X value? 0. That's going to go next. So, comma, 0. And then what's the next one that's going to go in here? 2. All right. We're just talking about X value. So, comma, 2. Then we have 3. So, it goes here. So, we got comma, 3. And then the last one is 5. And I didn't repeat any, so I kept writing them down. Comma, 5. And what do I close it with? The squiggly brackets. Okay. And that's a pretty ugly squiggly bracket. So let me try again. Although, I'll just tell you, mine are not the best. But I did write them, right? I want you to write them. So then what about the range? Well, the range here is going to be all the Y values. So let's come in here. Let's say this is going to be 9. That's the first one. 9 is the first one. So 9. And then what? Comma. We got a 3. That goes next. So 3 and then comma. And then what's next? -7. -7. Comma 3. Do we put a 3 here? No, because we got 3 already right here. Don't put another 3. That's what I'm saying about don't repeat. If you write another 3 there, on my test, if you're in my class, I'm counting that off. Your professor or teacher may not do that, but I am. All right? And then 7, which I don't have. I have -7, but that's not the same as 7. So list 7 out, and then close the squiggly bracket. And then say, okay, circle your answer. Is it a function, yes or no? Right, when you pass notes in elementary school, yes or no? Whatever. All right. So is it a function, yes or no? Well, do any of the x values repeat? No. So then it is a function. Those questions have different answers. Do any x values repeat? Yes. Then it's not a function. So the answer is no. If any of the x values repeat, no, then it is a function. Yes. They have opposite answers there. So none of the x is repeated, so it is a function indeed. And then for the next one, we have -3, -2, -1. -2 is right here, so don't list it again. -3, and it's over here. Don't list it again, right? So that means I have 1, 2, 3 elements in my domain. So my domain is going to be squiggly bracket -3, -2, -1, and I don't put the next 2 in there because I already have them, -2 and -3. I already have them. So then I come in here and say, okay, what about my range? So put my squiggly bracket. I got 3, 4, -5, 6, and 7. None of those are repeated. So 3, 4, -5, 6, and 7. And that's not a squiggly bracket. We're going to fix that. So there's my range. Is this thing a function? Well, did any x's repeat themselves? Yes. This x repeated itself here, and it has a different y. So guess what? That's not a function. Not a function. And going back to this first one, look, I know that the y repeated itself here, but remember, y's can repeat themselves. That's okay. It can still be a function if y repeats. In fact, you could have a bunch of different x's that don't repeat and all the same y, still a function. But if you have all the same x's and different y's, it's not a function because x cannot repeat. Y can repeat, but x cannot repeat. All right. So determine whether the relation is a function. Same thing going on here. We have 0, 1, 2, 3, 4. Do any of those repeat? Nope. So squiggly bracket 0, comma 1, comma 2, comma 3, comma 4. Squiggly bracket. Nothing repeated. What about the y values? We have 1 and then repeats itself, right? 2 and then repeats itself, and then -11. So we only have 3 of them, right? 1, 2, and -11. So let's come down here and say, okay, squiggly bracket 1, 2, -11. Is this a function? Well, do any of the x's repeat themselves? No x repeats itself. I know 2 of the y's do, but that doesn't matter. This is a function. The x's don't repeat. So this is yes. And then let's look at graphs here, and I probably could have made these a little bigger. They're pretty small on the screen here. Use the vertical line test to determine if the graph is a function. I want you to circle yes or no. So, is the graph a function? All right, yes or no. So the F question mark I'm asking, is it a function? So here you have a parabola first, right? You have this just big smile here. And if you recall what you know about parabolas, they actually keep getting wider and wider and wider forever, even though they look like they go straight up and down if you go far enough up or out to the side. But if you do vertical lines here, you never hit that graph more than one time. Whatever you do, you don't ever hit it more than one time. So it is a function, yes. The next one, probably some kind of cubic function or something. Looks like there's a stray mark on there, but it basically goes this, and this, and it again. It keeps getting wider and wider and wider forever. Okay, so again, if you look at this, any vertical line ever hit that more than once? Nope, there's no vertical line that hits that more than once, so that is a function. Again, they have different answers. Does a vertical line touch it more than once? No, then it is a function, yes. Okay, so here, let's look at the next one. The next one is a parabola, but sideways. So is there any vertical line that touches it more than once? Well, look, that right there, the axis, the y-axis. That vertical line right there touches it more than once. If you want to say, what about this, Mr. Guest? There's one that touches it. There's one. there's one, right? There's several. There only has to be one line that touches it more than once, vertical line, and it's not a function. So this is not a function because a vertical line crosses it or intersects it more than once. The next one is just a nice little line. Looks about 45-degree angle. We can't really tell, but it's just a nice straight line there. And if you start doing vertical lines on it, guess what? Doesn't touch it anywhere. More than once. More than once. So that is a function. And then the next one is an actual vertical line. Does it touch that vertical line more than once? Well, this one doesn't even touch it at all. But what about this line right here? That was terrible. But that line right there is the line, and it touches it definitely more than once, right? It touches it infinitely many times. So guess what? It's not a function. No vertical line can be a function because it's a vertical line. And then finally, you have this ellipse, maybe a squashed football, if you will, a circle that got somebody stepped on, right? A balloon that's about to pop, whatever, right? So you have this, and so is it a function? Well, look, again, the axis hits it more than once, but so does this line and this line and this line. I mean, it only has to do it one time, and that does it a bunch of times. So this is not a function. Not a function, right? So quick intro video here just on roster method and a graph. How do you determine if a relation is a function? And remember, a relation is just ordered pairs where you have one from each set. So we have an X and we have a Y. If the X is repeat, not a function. If the Y is repeat, that's okay. And you don't list the same thing twice. So it's assumed that if X repeats, it's a different Y. That's my point there. Okay. So an X repeating with a different Y is not a function. All right. Hope this helps. Good luck with algebra.